In problem 2, we're given this function right here. C of r is this expression, and r is the radius of insulation in a house's attic, and c is the cost of installing that insulation. And what we want to do is find the radius, find the thickness of the insulation that will minimize the cost. So we know to minimize something, we're going to take the derivative. Now, I know what I'm going to do here. Instead of using the quotient rule, I'm just going to bring this r up and write it like this. C of r is equal to 70r plus 7,000 r to the negative 1. Now let's differentiate. C prime of r is equal to 70 minus 7,000 r to the negative 2. And I'm going to rewrite it with that positive exponent as 70 minus 7,000 over r squared. Now let's set this equal to 0. So C prime of r equals 0 when 70 minus 7,000 over r squared equals 0. So we can solve this getting the LCD, which is r squared, and just multiply everything here by r squared. So we will get 70 r squared minus r squared times 7,000 over r squared equals r squared times 0. All I've done here is I multiplied through, right? Our LCD is r squared. I multiplied every single term by r squared. So first up I see is that these r squareds are going to cancel. And then we are left with 70r squared minus 7,000. That's equal to r squared times 0 is 0. So 70r squared equals 7,000. Let's divide by 70. R squared is equal to 100, from which we are going to get r equals 10 and negative 10 to solve the equation, but the negative 10 doesn't work here because this is the radius of some insulation. So we're going to claim now that the radius should be 10. Now, we could prove this. That's our only critical value, and it's the only one that makes sense here. So we could prove it by looking at 10 as our critical value here. Here's r, and then we could evaluate the derivative and see, do that first derivative test. But I'm not going to do it here.